Okay, this is lesson 50, polynomial equations, and we just didn't quite finish this lesson, so I'm just going to run through it real quick. If two polynomial expressions are connected by an equal sign, we have a polynomial equation. So a polynomial expression, those are the kinds of things we were looking at before. There was no equal sign, there was nothing to solve, but now we're going to look at polynomial equations, so they're always going to have an equal sign. The degree of a polynomial equation is the same as the degree of its highest degree term. So it's just like with a polynomial expression, you look at the terms, and whichever term has the highest degree, that means the sum of the exponents on the variables in that term is the highest for any term in the polynomial equation. That is the degree of the equation. So for this first equation here, x to the fourth minus 3x squared plus 2 equals 0, look at each term. X to the fourth is degree 4, 3x squared is degree 2, and the 2 is a 0 degree term because it doesn't have a variable. So the highest degree term in that polynomial equation is 4, is x to the fourth, so that is a third or fourth degree polynomial equation. The second equation has xyz plus y equals 4. That first term, xyz, has a degree of 3 because each variable has the exponent 1, x to the first, y to the first, z to the first. 1 plus 1 plus 1 is 3, so that first term is a third degree term. The second term is y, which has just a power of 1, so that's a first degree term, and the constant is a 0 degree term. So the highest degree term in that polynomial equation is xyz, and so it is a third degree polynomial equation. The last equation is y equals 2x plus 4. The y term has a degree 1, the 2x term has a degree of 1, and the 4 is a constant, so it has a degree of 0. So the highest degree term in that polynomial, both the y and the 2x are first degree terms, so that's the highest degree of any term in that polynomial, so it's a first degree polynomial equation. A first degree polynomial equation, such as y equals 2x plus 4, is called a linear equation because the solution pairs of the equation, when graphed in the coordinate plane, form a line. That means that any pairs of numbers that work in that equation for x and y, if you were to graph them on a coordinate plane, they would form a line. We can find solution pairs x, y for that type of equation by choosing values of x. So you look at your x term and you could choose a value for x, like maybe you would choose 2 for x and see what you would get for y in that equation. So 2 times 2 would be 4, plus 4 would be 8. So one of the pairs that would work in that equation would be 2, 8, if x were 2 and y were 8. So when we choose values in this kind of a function, in this kind of a polynomial equation, we choose values of x and we see what values we get for y with each choice of x. So we usually call x the independent variable because we just choose it. And then we call y the dependent variable because y depends on the value we choose for x. And since we usually do it in that order, we call x independent and we call y dependent. They both depend on each other, but because of the way we normally choose values, we call x independent and we call y dependent. The Cartesian coordinate system, the Cartesian plane, the xy plane, the Cartesian coordinate system, the coordinate plane, these are all names for the same thing, and this idea of having this Cartesian plane, this coordinate system where we have an x-axis and a y-axis, and we talk about locations in that graph, in that grid, that idea was worked on a lot by a very famous mathematician, scientist, philosopher named René Descartes. He lived in France and from 1596 to 1650. He's the one who said, "I think, therefore I am." He is often called the father of Western philosophy because the philosophies that he worked up and thought of and studied, along with a lot of other people, are the kinds of philosophies that we kind of live by in the West, meaning America, England, a lot of Western Europe. We kind of follow that kind of a philosophy. It was kind of based on a lot of Greek philosophies. All right. So he came up, he was, many things. He was a mathematician, scientist, philosopher, and so on. He came up with this idea of analytic geometry, which takes the idea of algebra, equations involving variables and things like that, and he relates it to geometry, the idea of drawings and diagrams and things. And he does that by using this Cartesian coordinate system. This is what the XY or Cartesian coordinate system looks like. The XY plane, we often call it. It's just a grid with a horizontal axis called the x-axis and a vertical axis called the y-axis, and the two axes are just number lines with the integers labeled. We locate positions or points in that plane using pairs of numbers. We talk about going a certain number of units to the right or left, and then we go a certain number of units up or down to get to certain locations in that plane. And we do that with this notation. We have parentheses, and inside the parentheses are two coordinates. The first one is always the x-coordinate, meaning the horizontal coordinate, how far to the right or left you're going to go. And the second number is always the y-coordinate, how far up or down you're going to go. The notation is very important. You have to have the parentheses. You have to have the comma in the middle. You have to have the correct order. X comes first, Y comes second. You have to use proper notation for this. So if I look at the points that are in this plane, let me just say a couple other things about it. The point that where the two axes cross, 0, 0, is called the origin. And that's where we always start when we are going to locate a point in the plane. We always start at the origin, right here where the two axes cross. That's the coordinate. It has the coordinates 0, 0. Also, the quadrants that these two axes break the plane up into 4 regions. This first region where x is positive and y is positive is called the first quadrant. Second quadrant is where x is negative and y is positive in this area. The third quadrant, where x is negative and y is negative, is called the third quadrant. And then the fourth quadrant is where x is positive and y is negative. They're numbered 1, 2, 3, 4 with Roman numerals, starting in the upper right corner and moving counterclockwise. All right, so we can name the points in this that are graphed here. This first point, that's in the first quadrant. If you look, we're going 3 to the right and 4 up. So that point is called 3, 4. 3, 4. It has to be in parentheses. All right, so that is how you would locate that particular point. This point here in the second quadrant, you're starting at the origin. You go 4 to the left and 2 up. So that point would be -4, 2. The first coordinate tells me go 4 to the left, and the second coordinate tells me to go up 2. All right, this point down here in the third quadrant is -2, -5, because if I start at the origin and go 2 to the left and 5 down, I get to that point. This point over here in the fourth quadrant is 3, -2, because if I start at the origin and go 3 to the right and 2 down, I get to that point. Graph following points on the plane below. The first point there is 4, 2, and that would be in the first quadrant. You would start at the origin, go 4 to the right, and 2 up. The second point is 4, -3. That's going to be in the third quadrant. You start at 0, 0, go 4 to the left, 3 down, and that's your point. That should have been -4, -3. So it was this one. Sorry, I did them out of order. So that's -4, -3. 4 to the left and 3 down is -4, -3. And then the last one, 4, -3, means go to the right 4 spaces and down 3. So that puts you in the fourth quadrant. So those are those points, and that is lesson 50.